Okay, so welcome back. So we'll continue our discussion on the recovery of metals from electronic waste that we have been talking about in this particular week so far. So this is the second module of the third week. So you have seen this. This was the last discussion we had in the previous video. We were trying to go over the different processes that goes in terms of recycling and recovery of electronic different components from electronic waste. So we'll continue the discussion. Now let's look at, that was the previous one we are looking at for this particular company, Cyanide companies are basically essentially from a Chinese firm. But today we'll look at the other company, and we'll go through, and you will see that there are several similarities and some of them are unique as well. So again, this has been collected by looking at their website, looking at the literature and other stuff of these different companies which is out there doing e-waste recycling. So in terms of this particular company, which is a Union Miner company's copper smelting flow sheet, where they are again scrap IC board they are using. So they have this scrap IC board to start with, and then that's then it says copper smelter is there, which is the slag. You have the copper smelter using the sulfuric acid plant. Then you have the slag, which is further treated in the blast furnace. So what in terms of copper pelletization is done, the recovered copper is pelletized. Then whatever is the precious metal is goes through a precious metal refinery, where copper like gold, silver and other are recovered. Then there are some special metals are also recovered using some different process. So it's just showing you a flow sheet of how the different process is run as part of this particular company, and we'll come back to each one of these detail very shortly. So if you look at the other option, this is our nearby. It's only like 2 hours from here, like Jamshedpur. So CSIR lab, the NML National Metallurgical Lab, they also have a process for pulverization of printed circuit boards. So the shredding and pulverization of printed circuit board, again they will have, if you look at the process, some of the process will be similar: magnetic separation, gravity concentration, froth flotation. You use the electrostatic separation, metallic powder, non-metallic powder. Then you try to do gold and silver recovery, and you have generate gold and silver powder. You do the acid leaching, and then with the leach solution you have the thiourea leaching. You get the solution, from there you recover gold and silver. You have the recovery of tin, lead powder, copper powder, iron and aluminum. So this is a kind of a combination of the physical as well as the chemical leaching, so that the combination of both is used. So of course some of these processes will be proprietary process, some of them will have the IP, intellectual property rights. So of course there are certain things, but as if you are if you are thinking of setting up in a e-waste recycling facility where you want to recover this precious metal, these are in broad picture, these are the different components that you need to go for. It's a combination of physical and chemical processes. Some of these chemical processes will talk about a little bit more in detail. Physical processes are the same as physical processes that is being used here is used for other things as well. It has been used for many years for municipal solid waste recycling. And chemical process also is not new. They are also used in the chemical industry for different types of applications, refining and other things, refineries, chemical refineries, metal refineries. That has been being used for many years. It is just the application of those processes in electronic waste stream, which is that's the new part. So in terms of the pyrometallurgical process that we are looking at, let's look at some of the example here. So what is the pyrometallurgical process? It includes incineration, smelting in a plasma arc furnace. So plasma arc, very high temperature, lot of energy required. That's why you have cost involved. You do the dosing, you do sintering and melting and reaction in the gas phase at high temperature. So all those things does happen. Then there are the traditional methods to recover non-ferrous metal as well as the precious metal from electronic waste. It has been in use for last 2 decades. People are using it for last 2 decades, so it's nothing like a brand new. And what is done in the process, the crust is scrap or burned in a furnace or in a molten bath to remove the plastic first. Then you have the refractory oxide from a slag phase together with some metal oxide. So, those are used for in terms of recovery of these are the like as a part of the process. Then material and entering the reactor, you put it in 1250 degrees centigrade. So, you does require like a pretty strong like a reaction chamber, which is churned by a mixture of supercharged air. So, up to 39% oxygen you have. So, up to 39% oxygen at 1250 degrees centigrade, you are trying to have an oxidation process. Then from a you make a agitated oxidation zone that converts impurities including iron, lead and zinc into oxide. So, and that get fixed in a silica based slag. So, then we cool the slag and then the slag is milled to recover more metals before disposal. So, these are different ways. Again, it's called Noranda process. So, this is a Noranda process which is being used and it's that's what it's used in other areas too. So, this is how like a metals could be potentially recovered from electronic waste. The copper containing a precious metal is removed and transferred to converter. So, after upgrading in converters, the liquid blister copper is refined at the anode furnace. So, you use like a furnace in the anode furnace and cast into anodes at purity of 99.1%. The remaining 0.9% containing the precious metal including gold, silver, platinum and palladium along with other recoverable metals such as selenium and other nickels are present in there. So, other things are recovered such as selenium, beryllium and nickel. So, those are present in the other 0.9%. So, those things are there. So, in terms of the process, if you can look at that. So, this is your Noranda process again. So, you have the recyclables coming in, you do some sort of shorting here. So, you have the recyclables coming in, then you do some sorting, shredding, like you make it small. You have the copper concentrate, 24% copper, sulfuric acid plant, Noranda converter, this is their IP thing, and then you have the reactors. So, basically converters. So, you use different process and get the copper out. So, this is in this particular process in which how copper is recovered. So, and this is a very copper, since if you remember from the percentages of different heavy metal, copper was the number one. So, copper recovery, and copper is a cost, like it's costly, it's not probably as costly as gold or silver, but it is also a precious it's a precious metal, and copper used in many applications in wires and other places. So, copper has a value, and copper is one of the highly recyclable metal as well. So, then this another process, Ronsker smelter. This is another application of pyrometallurgical process. Here it's done in Sweden. This is used in Sweden, in Boliden Limited in Sweden. This is known as the I hope I'm pronouncing it correctly, also known as the Ronsker smelter. In this process, the scraps are fed into the process in different steps depending on their purity, and high copper containing scrap is fed into converting process directly. Low grade e-waste is fed into the Caldo furnace. So, there is a different, so along the process chain, depending on the purity of your metal present, you put it in different, you input into the process at different level. So, that is what in Caldo reactor, blended feed material with e-waste and lead concentrate is charged by a skip hoist. You have an oxygen lane supply. So, you basically see whenever you do a combustion is an oxidation process. So, for oxidation you need to supply oxygen. We do many times we do not really supply oxygen, we supply air. So, sometimes we do supply oxygen if we do not want nitrogen and other gases to be present. So, oxygen lane supplies needed oxygen for combustion with an oil oxygen burner. So, this off gas subjected to additional combustion at 1200 degrees centigrade. So, very high temperature. So, mixed copper alloy is sent to the copper converting. So, we have copper, gold, all these are present in that. So, remaining dust containing leads, SB, cadmium are sent to other operations for metal recovery. So, this is a diagram for how the schematic Ronsker smelter. So, you have Caldo furnace, electronic scrap and lead concentrate coming in here, and it will go into the converting part, the refining, that will get lead. Then you have part of it going into the copper production. Copper, here you have the roasting, drying, smelting, some conversion, gas cleaning, sulfuric acid plant. Then you have the precious metal plant, nickel sulfate plant, crude nickel sulfate is selenium, gold is come out from there. What is happening exactly inside this? Of course, that is the part of the IP, so that you will not get those details. You have to, if you are planning to set up a plant, you have to get in touch with those companies to get those units. Like basically you need to buy those units and then you can use them. So this is again another example of how things are done. So if you look at all these examples, all these sketches that we have seen so far, there is some sort of commonality that essentially it goes through some sort of physical process and chemical process. The nature of process might be different. Different process works at different temperature. They have different operating conditions, and based on the operating conditions on the process, the purity and the recovery percentage will be different. And of course, the cost will also differ. So, but overall it is a combination of some sort of some physical process and some chemical process, and chemical process mostly it is a smelting or leaching and those kind of use of acid to recover metals. We know that metals have a tendency, metals do dissolve in liquid in acid in high concentration. So, that helps in terms of like a recovery of different types of heavy metals. So, then we have the Umicore, which is very common in Belgium. It is a Umicore precious metal refining process, which is a very common process. It's like most of the batteries around the world actually end up in this particular company. It's the first step in this precious metal operations. They abbreviate as PMO, is smelting using an ESA smelt furnace. So, again they have their own names. So, the smelter, it separates precious metal in a copper bullion from mostly all other metals concentrated in lead slag, which is further treated at the base metal operation. So, the precious metal it's separated with all other metals. The copper bullion is then treated by copper leaching, and electro winding and precious metal refinery for copper and precious metal recovery. So, that's happening over there. And base metal operation process is the byproduct from the precious metal like a PMO, which was the precious metal operation. And the main processing steps are you have the lead blast furnace, lead refinery, and a special metals plant. You have the there are a process which transforms the impure lead, nickel species, copper matte, and depleted slag. So, those the impure lead bullion that's collected most of the non-precious metal is further treated in the lead refinery, which is known as the Harris process. So, again these are the different processes that is being used. Then some of the special metals, their residues are generated in the lead refining process. Pure metals are recovered in a special air emission control system is there. Hygienic gases and process gases are cooled with energy recovery and cleaned using some techniques such as baghouse filter, electrofilters, and scrubbers and all that. So, again if you look at this process as well, it's essentially combination of different chemical processes that is happening, which is very similar to the previous process as well. Every process has their certain uniqueness and they work in a slightly different way. Then sulfur, because of the oxidation, sulfur is converted to SO2, which is converted to sulfuric acid. Emissions from the plants are well below the European limits because they have to meet the European limit standard. Then so those are in terms of the Uninor or Unicore process, Umimore process. Then other process like in this particular process in terms of the recovery of gold from e-scrap, which is it's by Dunn et al. In 1991, they put that paper out. So, here that you have the gold scrap, you react with chlorine at a temperature with a range of around 300 to 700. So, that makes a mixture of metallic gold. Then you have silver chloride and other metal chloride there. The mixture is actually washed with air sponge hydrochloric acid, and then you dissolve metal chloride other than the silver chloride, frame a metallic gold and silver chloride mixture. So, again as a course, I would not like those of the students who are taking this course, if you might be getting worried that there are so many chemistry here. Am I going to be tested on my chemistry? Am I going to be tested on all these small process definition and the description? My answer is no. In your quizzes or in your exam, those of you who are planning to take the exam, as I understand, many of these students of many of you who are taking this course, actually you are taking it for credit as part of some program in your university or in your colleges. So I'm not going to, we are environmental engineers, we are environmental scientists, we are not a hardcore chemist. So the questions will not be hardcore chemist oriented question, don't worry. Why these details? Then the next obvious question is, then why I have all these details? And just to give you an idea, say there are what are the different things goes into when we are trying to recover. So it's not an easy process. That's the reason I want to highlight that these are not an easy process. A lot of things goes in there, and then at the same time, this is not something rocket science, or these are not something which has something which has not been done earlier, or it's not being practiced in industry right now. These are all well established with right modification. These are standard things which is done in typical chemical industries and other metallurgical industries, refining processes, metal refining, especially metal mining. So these are all being used. It is just we have to take that process, maybe adapt it for the electronic scrap and use it over there. So that's what these companies or these organizations have done, and they have come up with these processes. They have patented those processes as well, and which is being used in a formal recycling of electronic waste in different places in Western Europe, North America and other places. In India also we have several companies set up now. Most of the Indian recycling companies doesn't go all the way of recovery of the precious metal. They actually go up to dismantling and try to recover some of the easier recoverable material, and then the hard one they again send it to Belgium and other places for further recovery. It will be really nice to get all those gold out in India itself, isn't it? And I think the gold consumption in India is probably the most in the world. So if I'm not, I think I'm correct. And then so that's, we have a big market for recovered gold here as well. So it will be nice to recover all this gold rather than sending it to say Belgium or other countries to recover gold on the e-waste that we have produced. See, I have already paid for my phone. So I have my phone, so if it has little bit of heavy metals present in there, little bit of gold, a little bit of silver, that should be stay in my country because I have already paid for it, and but it should not go to any overseas country. But we have to set up those facilities here. We have to set up those plants, and we have to get the waste coming to those plants. That's another, again, so I think I was telling in one of the earlier videos, the problem in India is not in terms of the rules, not in terms of the technology, not in terms of the technology. If there is if certain areas we may lack in technology, but technologies are nowadays available. You can buy those technology, you can have some sort of partnership as well with some foreign technology. But in terms of know-how, the problem is, it's even if there is a problem, it's a very minimal problem. The real problem is implementation. If somebody asks you what is the 3 major problem in terms of the Indian environmental system, I would say implementation. So we have to implement those like our rules and regulations, make the conditions suitable for our implementation. So that's where we lack. So there are lots of processes out there. We looked at some. Let's look at some more. So in terms of this process for recovery of gold from e-scrap. This was published nearly now. It's almost 20 years ago, like this was published. So it was ammonium hydroxide, nitric acid is used where you try to dissolve gold and silver, and you try to get the traces of metallic silver from metallic gold. So it's in terms of the dunce processing, what is developed for refining high grade gold material that contains more than 80% gold. So first of all, what we need to do for that? So we need to, in the electronic waste, we need to get rid of the other material. So what we will left with only the area which has gold and some other metals present, so that in that we can recover the gold from that particular process. So it may not work all the time. So it is clear that so in terms of if you look at the pyrometallurgical process that we have been trying to see in this particular lecture so far, there are traditional technology. It's in terms of traditional technology, the pyrometallurgy is used for recovery of precious metal from waste electronics. Is practiced for years. But however, most methods, even this, it gives rise to following limits. It's the integrated smelter. They cannot recover aluminum and iron as a metal. So that's one problem we have. And the presence of halogenated flame retardants in the smelter feed can lead to formation of dioxin unless special intermeasures are present. So those are that we have. So if somebody wants to do research in here, somebody wants to do some PhD in this particular area, these are the topic you need to look at. If you are a chemical engineer or a metallurgical engineer, the first topic makes more sense to you in terms of trying to come up with the recovery of aluminum and iron as well within the integrated smelter, how to make that possible. And if we are if you are an environmental engineer or even a chemical engineer, we can try to look at that how to get rid of this halogenated flame retardants in the smelter feed, so that we how to manage that, so that we don't have the formation of dioxins. And if there is a formation of dioxins, how to manage it, how to control it. That my environmental engineering student friends should focus on that aspect. So, and then we have some other issues like ceramic components and glass in the e-waste that increases the amount of slag from the blast furnace. And if you have more slag, then you have the loss of precious metals and the base metal from the scrap. We are only a partial separation of metals can be achieved using pyrometallurgical. So that's why we need to have some use other process as well. And hydrometallurgical technique or other electrochemical processing are subsequently necessary. So only pyrometallurgical process will not be enough. And the precious metals, they stay for a long time in pyrometallurgical process and are obtained at the very end of the process. So it's you have recovery does happen, but it happens towards the end of the process. So that's also it's a concern. So with that, we had a quick overview of the pyrometallurgical process. So now we'll look at the hydrometallurgical process, and we'll start this. Let's see, and then let's see how long we can make progress in this particular video, and then we'll continue in our next video. So in terms of the hydrometallurgical process, if you look at kind of an overview of that, it's a more exact, more predictable, more easily controlled. So this is a benefit on top of pyrometallurgical process, and the hydrometallurgical process, let's say we have a better control, and we can predict what will happen. And as it's a series of acid and caustic leaching. So essentially it's a sequential leaching, lot of leaching happening in this hydrometallurgical process. So we are doing a lot of leaching, and then in the process we end up producing a lot of hazardous waste as well. So we have to manage those hazardous waste, which we will see in a minute as we try to explain that. So here we have solutions. We are subject to separation and purification procedure. What we try to do, we try to play with solubility, we try to play with the solubility product. So we will have precipitation of impurities, solvent extraction, adsorption, ion exchange, all those typical stuff that we use for other treatment as well. So similar things are used to isolate and concentrate the metals of interest. So we try to do that. Final treatment, we try have electro refining process or chemical reduction or crystallization for metal recovery. So that's the final treatment is done as well in terms of electro refining process, chemical reduction is done, crystallization is done. So in terms of different types of method that is used, the most common, which has been until very recently, is on cyanide leaching, which is not actually the popularity of this method is going down because it produces cyanide, it produces a lot of hazardous waste along with that. It is an electrochemical process and it is used in mining industry for more than a century. It is being used. So it's its overall reaction, what happens is you have gold, it reacts with cyanide and produces gold cyanide complex, and then you have like a basic conditions like OH minus is also produced. So what it does, it's the gold present in the solid form in those electronic waste or in the ore get dissolved into the liquid form. So maximum dissolution of gold, silver, palladium and platinum, it happens at the pH of 10 to 10.5. So it happens in a caustic environment, in an alkaline environment around 10 to 10.5. The order of reactivity, like we have more reactive is gold, then the silver, then palladium, then platinum. So, those are in that sense, in that sequence the reaction takes place. So, and they use halide system for gold dissolution, predates like a cyanide for so halide is also used, like fluorine, chlorine, bromine. They used to use gold dissolution or before cyanide use. Gold forms both Au1 and Au3 complex with chloride, bromide and iodide depending on the solution. Solid chlorine and chloride has been applied industrially on a significant scale. So, that is the halide leaching is also done. So, so cyanide leaching is done, but even before cyanide leaching, halide leaching has been practiced. So, these are all practices which is being used in the gold mining. So, we are trying to use the same process which have been used in gold mining. Gold mining also, gold is not free, it is with certain other material, other mineral, other complexes are there. So, similarly in for electronic waste, the gold is present with other complexes and other things. So, we are trying to use the same concept in terms of the recovery of gold from electronic waste. So, in terms of the halide leaching, where here it is a chlorination it's a low pH, high chloride, increases temperature, high surface area. So, first step here is use dissolved gold in aqua regia, and the reaction involve these process. So, you make first aqua regia and then you dissolved gold in aqua regia to make that gold solution, and then you can recover it from there. So, chloride leaching of gold is more difficult to apply than cyanide extraction because for chloride leaching you need a special stainless steel and rubber line equipment to resist the corrosive acidic and oxidizing condition. Chlorine gas is highly poisonous and must be avoided at any health risk. If you think about, if you go on YouTube and look at how the e-waste is managed in the informal sector, you will see that people are using aqua regia in a highly open atmosphere without any kind of protective air pollution control thing, and then they have all this chlorine gas and other things out there which is being exposed. So, all these workers in the informal sector is getting exposed, and the goal there is only to recover that little bit of gold, and they in the process, since the process is not in a, it's not a refined process, it's not as it's done in a very crude manner, they also lose a lot of gold. So, it's not that they end up losing gold as well, but that's their the way they manage it. It's just to recover whatever they can recover, and since they don't have to follow all these SPCB and CPCB rule, the cost wise it works out for them. But it's the same thing that is done in the informal sector. In the same process could be used in a formal environment with a better environmental control, but with better personal protective equipment, so that the workers working there doesn't get exposed to all these chemicals and doesn't get sick. Most of the informal e-waste workers doesn't stay alive for a long. Many of them don't see their 40th birthday. So, they die before they reach 40 years of age because of getting all these things exposed day in and day out for several years. So, there are issues in that. So, with that, let's we looked at some of these hydrometallurgical process. So, we will continue the discussion again in the next video. So, I hope that you are enjoying this course so far. Again, any questions, any suggestions, any feedback, send it to us through the discussion forum. Thank you, and I will see you again in the next video.